the earth on an object. Clear? So this is mass and weight. Total content of the body is called mass, and force exerted by the earth on an object is called weight. We have to find some difference between mass and weight. Some difference between mass and weight. Okay. Draw a table regarding mass, the first column, and weight in the second column. First difference is the definition itself. First difference is the definition itself is the first difference. What is the definition? Total content of the body. Total content of the body. What is weight? Force exerted by the earth. Force exerted by earth. So what is the second one? Mass is a scalar quantity. Mass is a scalar quantity. What is mean by scalar quantity and vector quantity? You already studied in the chapter motion. So mass is a scalar quantity and weight is a vector quantity. That means mass has only magnitude while weight has both magnitude and direction. Third one, mass is constant. Mass is constant. This is important that we need a clarification regarding this point. Mass is constant while weight is vary. So we need clarification regarding mass and weight. In this point, mass is constant and weight is varying. That we have to explain briefly this point. And again, the unit of mass is kilogram. Unit of mass is kilogram. SI unit, internationally accepted unit. While the unit of weight is either Newton, because weight is force, Newton, or otherwise there will be another unit. What is another unit? Weight is equal to mg, that is kilogram meter per second square. So these are the difference between mass and weight. Total content of the body is called mass, while the force exerted by the earth on an object is called weight. Mass is a scalar quantity while weight is a vector quantity. Mass is constant while weight is varying. And finally, the unit of mass is kilogram and the unit of weight is Newton or kilogram meter per second square. This point, what point? Mass is constant and weight is varying. This point need more clarification. For that one, we consider Earth to be a perfect sphere, or otherwise the accurate shape of Earth called approximate, not approximate, the accurate shape of Earth called geoid. Consider the Earth. Earth is in geoid shape. This is the shape of the Earth. Okay. So here is the equator. It's an imaginary concept, as you all know. This is an equator. This is the equator, and these are poles. Okay. So this is the radius. This is the center. This is the radius R. From here to here is also radius. From here to here is also radius. From here to here is also radius. What is the peculiarity of the radius? As we all know, that radius of a material is always constant. But due to the peculiar shape of Earth, the radius is slightly varying from equator to pole. That means radius is maximum at the equator and the radius is minimum at the poles. Radius is maximum at the equator and the radius is minimum at the poles. What is the equation for weight? What is the equation for weight? Weight is equal to, equation for weight. Weight equal, equation is mg, right? Weight equal to mg. That is, weight equal mass into gravity. Gravity means acceleration due to gravity. As we all know that the value of acceleration due to gravity, g is equal to 9.8 meter per second square, right? 9.8 meter per second square. Is that constant? It is not constant. the acceleration due to gravity is slightly varying, that we have to discuss here. Okay, so weight is equal to mg. Mass is constant. If g is also constant, then weight is constant, right? Mass is constant. When if g is constant, then constant into constant, weight is also constant. But already we say that weight is a varying quantity, mass is a constant quantity. So there will be no confusion regarding the mass of the particle. Small letter m, mass is always a constant quantity. So what about weight? Is that weight varying? Already we say that weight is a varying quantity. How the weight of the particle is varying? So is there any chance the weight of the particle is to be constant, or is there any chance the weight of the particle is varying? So for that we have to discuss that, or we have to assume that Earth to be a perfect sphere or a perfect geoid in shape, and this is the equator and this is the poles. As we all know that a single particle have a single radius, but here due to the peculiar shape of Earth, the radius is slightly varying. The radius is maximum at the equator and minimum at the poles. Okay, so this is weight. Weight is equal to mg. What is the equation for g? G is equal to, already we studied, capital letter G, capital letter M by capital letter R square, right? Where capital letter G is the gravitational constant, capital letter M is the mass of the Earth, and capital letter R is the radius of the Earth. So capital letter G, capital letter M by capital letter R. This R is radius of the Earth. As we all know that the radius of the Earth is constant, but due to the peculiar shape of the Earth, the radius is slightly varying. Okay, we want to discuss. So G and R are inversely proportional, right? G and R are inversely proportional. Whenever G increases, what happens? Whenever G increases, that means R is decreasing. That means whenever R increasing, G is decreasing. Whenever R decreasing, G is increasing. That means G and R are inversely proportional. From this equation, it is clear. G and R are inversely proportional. Then one quantity increases, other quantity automatically decreases. Okay. Now, from the figure, from the shape, it is clear that number one, first condition is that R is maximum at the equator. What happens? Whenever R is increasing, small letter G decreasing. So whenever R is maximum, G is minimum. Small letter G is minimum. So R is maximum at the equator, R max at the equator. Therefore, G is minimum at the equator. Here, G is minimum at the equator. What happens? G is minimum. So what about this equation? Weight. Weight is equal to mass into gravity. Weight and gravity are directly proportional, right? Whenever G increases, weight also increases. Whenever G decreases, weight also decreases. In these two equations, it is clear that weight and gravity, acceleration due to gravity, are directly proportional. But here, gravity and the radius of the Earth is inversely proportional. Okay. Our weight and gravity are directly proportional. That means whenever weight increases, that means whenever G increases,